Number 5. An electron traveling horizontally enters a region where a uniform electric field is directed upward as shown in the given diagram. What will be the direction of force exerted on the electron when it enters into the field? We have option A, option A upward, option B to the left, option C downward, option D to the right. Let's see which option is correct. The electric field is directed upwards. Since the electron has a negative charge, the force on it will be in the opposite direction to the electric field. Therefore, the force on electron will be downward. As the electric field is directed upward, so the force exerted on electron will be downwards. So we have correct option as option C. Now let's move to the question number 6. In which of the following media the force of Coulomb decreases more as compared to the vacuum? Options are option A gases, option B metals, option C liquids, option D insulators. Let's see which option is correct. Insulators generally have higher dielectric constants compared to the gases, liquids and metals. Therefore, the force of Coulomb decreases more in insulators compared to the vacuum. We can also clarify this with the force formula. As we see that the dielectric constant relative permittivity is inversely proportional to the force. So insulators have greater dielectric constant, therefore they have lesser Coulomb force. Therefore, the correct option is option D. Now see the question number 7. A student has been tasked to get maximum power dissipation by different dry cells in a laboratory. To fulfill this task, she or he should keep in mind that the effective internal resistance must be option 1 equal to the external resistance, option 2 less than external resistance, option 3 more than the external resistance. Let's see the answer. The power dissipated in the external resistance is given by this formula. From this formula, we can say that lesser the denominator, greater will be the maximum power dissipation. So, for this case, if the effective internal resistance is equal to the external resistance, we can have maximum power dissipation. So, if this factor is 0, then we have the maximum power dissipation, and this factor will be 0 when capital R is equal to small r. That means when external resistance is equal to internal resistance. So, therefore, we have correct option as option A, 1 only. Now see the question number 8. The terminal potential difference of a battery is equal to its electromotive force when its internal resistance become option A low, option B 0, option C high, option D constant. We have from this we have this formula that electromotive force is equal to the IR, capital IR plus capital I and small r. When the internal resistance of the battery is 0, we will have the terminal potential difference of a battery is equal to इलेक्ट्रोमोटिव फोर्स। जब हमारे पास ये जो इंटरनल रेजिस्टेंस है वो इक्वल टू 0 होगी तो हमारे पास टर्मिनल पोटेंशियल डिफरेंस इलेक्ट्रोमोटिव फोर्स के इक्वल होगी। सो वी हैव द करेक्ट ऑप्शन एज ऑप्शन बी।